Hi ladies, in this video we're going to go through the difficult questions for 8C. So just scrolling up just to remind you of the key ideas. So the addition rule is here. Okay, so make sure you've always got that written somewhere nearby so you can refer to it. Don't think you can always remember it off by heart. And just remember, mutually exclusive events are just slightly different. But even if you didn't treat it as mutually exclusive, you'd get the same answer anyway. All right, let's scroll to and quickly do question 6. So, all right, let's get my pen ready. All right, of 32 cars at a show, 18 cars have four-wheel drive, 21 are sports cars, and 27 have four-wheel drive or are sports cars. Okay, so I always like to represent a question either as a Venn diagram or a two-way table. My preference is for two-way tables. I just find them so much easier to read. So we're going to use F for four-wheel drive and S for sports car. So in your two-way table, we've got F and not F, S and not S. And then we just finished drawing our table. My stomach is rumbling. I haven't had any lunch. Not that you really need to know that, but anyway, the day's nearly over. All right, so 32 cars. So your total always goes here. The good thing with a two-way table is you can usually, if you've got enough information, you can fill this all in and you probably don't even need to use the addition rule, but I'm going to show you how you can do both. So don't think just I'm going to take the other way because this is 8C addition rule. I'll show you the addition rule as well. Okay, so 32 in total, 18 cars have four-wheel drive. So we go four-wheel drive in total 18. So some of them are sports cars, some of them aren't. And then 21 are sports cars. So of those 21 sports cars, some have four-wheel drive, others don't. Okay, but we don't know how many that is, but we know we have 21 in total. And 27 have four-wheel drive or are sports cars. Okay, so that means that 27 is made up of 27 is either a sports car or, not and, or a sports car or a four-wheel drive. So that means we have 5 that are neither. So we can actually put a 5 in here. So if 27 are either a sports car or a four-wheel drive, then 5 are neither. Okay, and then we've got enough information to actually complete this diagram. So your rows add up. So 18 plus 14 gives us 32. Then this way we're going to have 11. We're going to put 6 here, then that's going to be 12, and then lastly 9. So for question A, we want to know the probability that a car randomly selected at the car show is both four-wheel drive, and a sports car. So that's this cell here. I always circle it, and I realized when I watched the video the other day, I don't usually watch my videos back, as awesome as they are. No. I realize when I go like this, you can't actually see my pointer. I can actually change that. Maybe I should. So 12 over 32 cars in total, and then we can simplify that to become, not 4, sorry. 4 is the highest common factor. 3 over 8. Now, you can get the same answer using the addition formula. So we want the we don't want, but the addition formula is this. So I'm not using A and B, I'm using F and S. So I'm just writing the the addition formula and minus, whoops. Let me just check that I've actually written it correctly because I always get it mixed up. Okay, probability of A plus the probability of B minus the probability of A and B. All right, so for this question here, they've told us, let me just go back up, told us that 27 are either a four-wheel drive or a sports car. So that probability of F or S is 27 over 32. The probability of F, so we have 18 four-wheel drives and we have 21 sports cars. And the probability of F and S is what we're trying to work out. So even though I've already done the answer, I'm now showing you using the addition rule. Okay, so let's just tidy things up a little bit. So 18 plus 21 gives me 39. And then let's get X on its own. So we're going to have 39 on 32 minus 27 over 32 gives you 12 over 32, which is what we had before. So 3 over 8. So you can see you could use the addition formula or addition rule, or I like two-way tables. We can get the answer straight away. And the two-way table actually, oops, oh gosh. Word keeps freezing for me today, so let's hope it doesn't freeze while I'm doing this. You're often asked other questions. So for question B, we can use a two-way table as well. So find the probability that a randomly selected car at the show is neither four-wheel drive nor sports car. So that's this number here. Let me just circle it in green, is 5. So the probability of not F and not S is equal to 5 over 32, or you can do it the same way as we can do is equal to 1 minus the probability of F or S. So 1 minus 27 over 32 will give us 5 over 32 as well. So sometimes you can do minus what you don't want. So we don't want F or S. In the question it told us it was 27. 27 cars are both F and S. So 1 minus what we don't want gives us 5 over 32 as well. But see how the two-way table, very helpful, girls. All right, so question 8, I'm going to set up a two-way table again. So for 8A, and I had a look at the solution for this one because I thought, oh, should I be using the addition rule? But I'm not going to use the addition rule. The addition rule, I think, will complicate it, but you can use the addition rule if you like. Okay, so let's have a look at what we have. And you can see our probabilities are written as decimals, so there's nothing wrong with that. Okay, so we know the probability of A or B is 0.8, so that means neither of them is going to be 0.2, so 0.2 can go in here. The probability of A, so down here, is 0.5, and altogether they have to add up to 1, so that's probably a bit more helpful. Probability of B is 0.4, and then we can just fill in the table. So this is going to be 0.6. This is going to be 0.5. This is going to be 0.4, leaving this to be 0.1, and this is 0.3. Okay, so using that information to fill in your two-way table. Now we want to find the probability of A and not B. So you can read it straight from your two-way table. We want to look at the probability of A and not B. So it's here. Okay, so A, not B, 0.4. And we don't have to do over 1 because that's just equal to 0.4. Have a go at doing question B on your own, filling in the table. Actually, I might do it as well with you. But just remember, this is a probability of A or B. So you can do the probability of not A and not B, which would go, and I'm circling something that you can't see, but we'll go where this 0.2 is. All right, so let's just be quick. A, not A, B, not B. It's a bit hard to see because I don't have the question there, but I'll do some quick scrolling. Okay, you don't have to use a ruler with your tables as long as you can draw a straight line. Okay, A or B, 0.76. So that means in here, we're going to have 0.24. Okay, what we don't want, and that adds up to 1. So A or B, 0.76. So not A and not B is going to be what we have left over. Probability of A is 0.31. And then I think we also get the probability of B, 0.59. Okay, so again, just adding everything up. If you have trouble doing this in your head, use your calculator, but you should be able to do these somewhat easily. I'm just, as I say that, I'm like, what is it? All right, 0.17. Okay, so this is going to give us 0.14 and then 0.35. No, 45. There we go. All right, so now that you've got this table, you can actually work out the probability of anything. So I'm going to just go back up and see what it's actually asking for. Not A and B. So not A is this column and B, so we've got 0.45. So the probability of not A and B is equal to 0.45. Now you could use the addition rule, but I think it's a lot more complicated to use the addition rule than it is to actually draw a two-way table. And I think that was it for my challenging questions. All right, bye girls.